Eric, let me invite all the panelists back along with Rushna. We have about 5 minutes, 6 minutes for a quick lightning round of questions. And I'm going to ask you all the same question. Given what you know about the field that you're all working on, and Rushna in particular, I'm going to start with you. You have 5 decades of experience working with AI. What do you see going forward? What do you see the big challenge will be and the big contribution would be? So we'll just go, I'll start with Rushna, then go to Duncan, then Shankar, and Eric, you can have the final word.
Well, it's hard to follow these folks who are, such giants in this area, but I will start with the following. When I was a student of John McCarthy, who invented the word artificial intelligence, he meant something different than what's today AI. He meant what he called representation. What he was really interested in, that how do we take all this information in the world that you heard, either it's sensory information or is it social information, you name it, and how do you translate it into some what he called representation that you can store in the brain. And of course, he was in Princeton at that time and worked with people like neuroscientist McCullough and so on. They showed him that what the brain actually has is all these spikes. So the question was, how do you translate all this rich information that is out there and you convert it into these spikes, and yet people make sense out of it? Now, getting forward 50 or 60 years from now, what we experience is, and again, I am afraid that the software people are getting more credit than they should, because in some ways, the reason that we have this new AI, which is really basically data-driven interpretation of data of various kinds, either it's measurements or typed in or whatever way of you collect the information, is really thanks to the engineers who created a very inexpensive PCs, processors, very inexpensive data storage. And hence, as Shankar showed, these circles overlapping the data, the IoT, which is again taking all the data and transmitting it to, at the distance, short or long. It allows you to have communications at various places, so IoT, and then you have the big data, and you have the cloud, which is really again a large data center where the electrical engineers and material scientists enabled us, the devices, to store all this information. So then, given all of that, you could then use the people, the algorithmic computer scientists, who can then use this hardware and process this measured data, but also make inferences and so forth and so on. So the reason I'm saying this, because I really think that the proper credit should go much broader to not just the computer scientists, but all the scientists. And I, as an educator, I feel very obliged that all the scientists, the engineers and the mathematicians and material scientists and biologists should get all credit for giving us understanding to process all this information and deliver all those beautiful digital transformations that Shankar talked about.
Thank you, Rushna. We're really running low on time. So Duncan, You have 15 seconds. Sorry.
Thank you. I will say, as a computational social scientist, that one fascinating transformation that I see coming is that all of this attention that that AI has brought to questions like fairness and ethics and even common sense is actually revealing that there are problems and misunderstandings and ambiguities that have been present with us all along in our own behavior and in human behavior and human institutions that we had sort of been able to ignore or gloss over. And when you have to put them in code, and when you see in a very concrete way how they manifest themselves through algorithms and even physically in robots, it becomes much more clear where the gaps are. And so I think that in teaching computers how to think like people, we're going to learn a lot about how people think as well.
Thank you, Duncan. Shankar?
We've done a lot. I think the AI algorithms have done well on, I think, the simplest classes of applications. I don't mean there's such as speech and image, and because these are essentially low-dimensional phenomena. I think the reasons that deep learning and neural networks work to extract these low-dimensional features. On the other hand, I think the real premise, as was pointed out by Duncan, is really to try to understand messy human decision-making with its biases, with its time variation, and its implicit changes, and problems with the algorithms. Because these, what's at stake here is really how we live. And it's really important that, and I think Duncan said it, I think it's not just teaching a computer to act like a human, it's like teaching humans and computers to interact with each other in a much more meaningful fashion. And that, I think, is both exciting and frightening at the same time.
Great, thank you. Eric, you have the last word. 15 seconds, please.
Yeah, I'd say we're gonna, building on Duncan and talking a little bit about going from society to biology and neuroscience. We're gonna learn a lot about human intelligence from probing these machines and pushing hard on them. We're gonna see some foundational advances in beautiful interactive tools that will augment our abilities, that will help us in the sciences. We're already seeing great work in material science and biology and visualization. And I think we're coming into a really interesting regulatory regime. We're going to see some intensive regulation that will hopefully provide some good guidance to the field and aim the technology in the right places.
Thank you, Rujna. Thank you, Duncan. Thank you, Shankar, and thank you, Eric. I'm going to hand it back to Rowena.
This was terrific, and I've learned a great deal. And I think my grandchildren probably have learned a great deal as well. But I just want to recap Duncan's statement that in teaching machines to think like people, we're learning a lot about how people think. And I found this very exciting and want to thank you both, for Rosina and Vijay, for organizing this second half of our AI education.
If I can say one thing, that the American Philosophical Society should continue this conversation because it's so integral into our human skin, human body, and the human society that you cannot ignore the ramifications of the technology on the human society. And as Eric mentioned, the whole neuroscience and medical science and economy and you name it, everything is interconnected and technology is the glue. And so the American society should really pay attention to it.
I think they will.
Good.
Thank you.
Thank you all.